Yes. Good day, students. We want to continue from our equilibrium in chemistry. We want to talk about equilibrium constants. Equilibrium constants. Now, what is equilibrium constants? Equilibrium constants is the ratio of the velocity constant. The ratio of the velocity constant of the forward reaction and the velocity constant of the backward reaction of a reaction at equilibrium. Mathematically, K is equal to K2 over K1 or K1 over K2, where K is equal to equilibrium constant. K2 is the velocity constant. Velocity constant of the backward reaction. And K1 is the velocity constant of the forward reaction. You will not see or not understand this now until I get there. There is something I will explain that will make you to understand what I'm talking about. But anything I'm saying now may seem to be a jargon now. But I can assure you, very soon, you will understand what I'm talking about. What do we mean? There are two scientists. One they call Gutenberg. The other one is called Wald. They are the foundation of equilibrium constant. So the concept of equilibrium constants began from the postulation of the law of mass action. The law of mass action by Gutenberg and Wald. Now, these two men, Gutenberg and Wald, stated the law of mass action. That was where this thing came up. What is the law of mass action? Let's look at the law. The law of mass action is similar to the rate of the rate law. Mass action. The law of mass action. This law states that the rate of a chemical reaction, is directly proportional to the concentration of the reactants raised to the power of its coefficients in a balanced equation, balanced chemical equation. The law of mass action states that the rate of a chemical reaction is directly proportional to the concentration of the reactant raised to the power of its coefficient in a balanced chemical equation. We can still say that this law also states that the rate of a chemical reaction is directly proportional to the active mass of the reactants. To the active mass of the reactants. I will still explain what all these things mean. They have meaning. Chemistry is not abstract. There are meaning. What do I mean? Let me first interpret this one. It says that the rate of a chemical reaction, whether a reaction is going to be fast, it's going to be slow, depends on the concentration of the reactant. The higher the concentration, the slower the rate of reaction. The lower the concentration. If you in a chemical reaction, if you use a dilute acid contains little acid inside plenty of water. Is that not it? That reaction will be slow because the concentration of the acid is what is low. Are we there? But if you use a concentrated acid, the reaction will be faster. Because in a concentrated acid, you have much of the acid inside a small amount of water. Am I talking to you now? So that is what the law is talking about. The higher the concentration, the faster the rate of reaction. The lower the concentration, the lower the rate of chemical reaction. Then we now say, the law also states that the rate of a chemical reaction is directly proportional to the active mass of the reactant. What is active mass? What is active mass? Active mass. Active mass. Active mass. What is active mass? Active mass of a reactant is the concentration of the reactant raised to the power of its coefficient in a balanced chemical equation. What do we mean? For example, if a reaction is A plus B equals to C plus D. This is a balanced chemical equation now. This A, small letter A, means what they use to balance it. Just like, okay, we are playing the board. If it is 2, can be 1. What you use to balance this particular molecule is this small A. What you use to balance this one is this one. Am I talking? According to the law of mass action, the rate of a reaction, let me do small letter R. The rate of a reaction is equal to the concentration. Okay, let me say R1. Okay, R1 is equal to the rate of, it's proportional to the concentration of what? A. Rate to power of what they use to balance it. Am I talking to you? Yes, sir. So, and here also we can say R2. The rate of R2 is what? B. Rate to power B. Am I talking to you? The rate at which this reaction will take place. Two things make up the reactant now. A and B. And that rate is proportional to the concentration. When you see this type of bracket, block bracket, it means concentration of what is inside. Are we there? It's proportional to the rate of this. So here now, we can have R equals to K1. We introduce a concept to change this one to equality sign. Abi? A raised to power what? A. This one can also be what? R2 is equal to what? K2 into what? B raised to power what? B. Am I talking to you? And don't forget that A and B are the reactants of this reaction. Am I talking? Yes, sir. So, according to law of mass action now, according to the law of mass action, okay, let me change this one. Let this one be a reversible process now. The rate of forward reaction, the rate of forward reaction R1, let me call this R1 now. Let me call this one RA. Okay, let's do that. Then R1, or let me call this one RA. The rate of the forward reaction, or R figure 1, is proportional. You know, this is the forward reaction now. Hello? In the forward reaction, we only need the reactant, the concentration of the reactant. We don't have this with the concentration of the word of the product. Are we together? What are the two things we have in the reactant? We have A, raised to power A, you have B, raised to power D. Why don't we put this plus? You know, between them there is an invisible times. Are we there? Why the times? In mathematics, in probability, and means what? And A and D means what? And means what? Times. In probability. Are we there? So, in the reactant contains A and B. Are we there? So that is why we are having this. So we can now say, okay, introducing K. We can R Roman figure 1 is equal to K into A, B, B. Now, let me call this one now Ki. Are we together? Yes. Then what is Ki? Ki is what? Velocity constant of the forward reaction. Ki now is what? Velocity constant. To change this sign to what? Equality sign. Are we there? Velocity constant of the forward reaction. Now, let me clean here. So the next thing to look at now, this is for the forward reaction. What about for the backward reaction? For the backward reaction, we have R Roman figure 2 is equal to, is proportional to what? You know, for the backward reaction, the reactant are C plus D. Am I talking to you? Yes. And it's only reactant to have business with. So we have C raised to power C, then we have D raised to power D. Then we have R22 is equal to K22. Then we have C raised to power C. Nobody will have to derive this thing and derive it. Don't worry yourself. Now, this is the rate where Kii is the what? Is the velocity what? Velocity constant for the backward reaction. Then Ri is what? Rate of forward reaction. And RII is what? Rate of what? Backward reaction. Am I talking to you? Yes. In the first equation we got here, this one is what? Rate of forward reaction gave us this one. Am I talking? Yes. The rate of backward reaction gave us this one, Abi. And when we're looking at the conditions for equilibrium, I told you that the rate of forward and backward reaction will be equal. Abi? The rate of the forward reaction. So, since the rate of forward and backward reaction must be equal for equilibrium to be established. That is, RI must be equal to RII. RI must be equal to what? RI. And what is RI? RI is equal to what? Okay, let us put it. What is RI? We have KI A raised to the power A B raised to the power B is equal to what is RII? RI is KII C raised to the power C, then D raised to the power D. Are we together? Are we together? Please, let's look up. Divide both sides by K2. KII first. Hello, look up. We want to divide both sides by KII. We will now have what? KI A raised to the power A, B raised to the power B. Everything divided by what? KII. Am I talking? Is equal to what? The KI, this KII will cancel now, Abi. KII C D over KII. So this KII cancel this KII. Am I correct? Are we seeing what I'm doing here? Okay? Let me clean here now. Nobody will have to derive all this rubbish, but here we are going to use it. I'm going to tell you, we are going to solve questions regarding that. Now, then the next thing to do, we have gotten this. This one can be rearranged as what? KI over KII. Am I correct? Times what? A raised to the power A. B raised to the power B, right? Is equal to C raised to the power C, then D raised to the power D. Are we together? Am I correct? Am I saying something good? Then the next thing to do is to divide again. Divide both sides by A B B by A B B. So what do we have? We have KI over KII, A raised to the power A, B raised to the power B, everything raised to the power A raised to the power A, B raised to the power B is equal to what? C raised to the power C, then D raised to the power small letter d over A raised to the power A, B raised to the power B. So this one will now cancel what? This one. We now have what? KI over KII is equal to C raised to the power C, D raised to the power D over A raised to the power A, then B raised to the power B. Then what is KI over this one? KI, okay, which is equal to K. Now, KI over KII is the same thing as what? K. And what is K? That is equilibrium constant. When we started, I told you that there is something you will not understand until I come to the end of this story. I define the equilibrium constant as the what? As the ratio between the what? Between the velocity constant of the forward reaction and the velocity constant of the backward reaction. Am I talking? Which is K. Equilibrium constant is what? K equals to what? This one over this one, which is the same as what? As this one. Am I talking to you? Now, types of equilibrium constants. Types of equilibrium constants. equilibrium constants. There are two types. There are two types of equilibrium constants. These are, the first one is called equilibrium constant for concentration. Equilibrium constant for concentration. That one is Kc. While the second one is equilibrium constant for pressure. Equilibrium constant for pressure. Okay. So the next one, number 2, is equilibrium constant for pressure. That's Kp. Now, what's the difference between Kp and Kc? What's the difference between equilibrium constant for pressure and equilibrium constant for concentration? Now, Kp is applicable for a gaseous system, while Kc is applicable for non-gaseous system. So, concentration is applicable to what? Liquid, aqueous, solid. But pressure is applicable to what? To gases. So take note of that. Now, let's look at classwork for this work now. Classwork. If they ask you, number 1, write an expression for the equilibrium constant. For the equilibrium constant for the following reaction equation. What's the equation? Abba process. Let me use Abba process. I have N2 gas plus H2 gas equals to NH3 gas. So here I have 2, here I have 3. This is what we do. Something that must come to your mind is that what type of system is this one? Gaseous system. What type of equilibrium constant are you looking for? Kp. And it must be product over reactant. What did I call it? Product over what? Reactant. I will now say Kp will be equal to, what is my product? This. I will have NH3. I will not write this to. I will not write this coefficient. I will put it up. Then divided by, what are the reactants? N2 and what? H2 abi? Raised to power 3. This one is raised to power 1. It's either you put the 1 or you did not put it. Are we together? That is the answer. But there are some times, like, what about number 2? Okay, for this first one. So let's look at the second one. If you have Fe solid reacting with steam, with then it forms Fe2O3. O4 plus H2 gas. Okay, I have 3 here. This 4, I have 4 here. And I have 4 here. Please look at this. This one is a mixture of solid gaseous system. A mixture of solid what? Gaseous system. So we are going to separate gaseous system from the non-gaseous system. So you are going to have both Kp and Kc. Let's look at the Kp. The Kp will not be, what is the product? The gas. Only the gas are the product. That's H2 raised to power what? 4. Divided by what is the reactant? H2O raised to power what? 4. This is the Kp. Then the Kc now will now be Fe3O4 raised to power what? Nothing. Then over Fe raised to power what? 3. So this one now, since it contains combination of what? Concentration, it contains a mixture of what? Solids and liquids. So we have Kc and Kp separately. Can I clean the board? Want to look at jam questions now. Now let's look at these wire questions. Before we now look at some jam questions. Here, the first question there says, chemical equilibrium is attained when what happens? Let's read the options one by one. A. All the reactants have been completely used up. Does it make any sense?
No.
Because a system at equilibrium must not come to completion. So if all the reactants have been completely used up, then equilibrium will not be what? Established. So it's not the answer. B. The reaction goes to completion. No. This one will continue to react with this to form this. This one will be forming this one. This one will be forming this one to continue like that. Reaction must not come to completion. So B is not the answer. C. The concentration of reactants and product remain constant. Does it make any sense? The concentration of reactant, it's one of those things I stated, number 8 or 7. Yeah. Concentration must remain constant, temperature must remain constant, pressure must remain constant. So answer now is what? C. But they must not be the same. Look at here now. Take what is the difference between this option and option D. The concentration of reactants and product are equal. Are they equal? No. But they remain what they are in their respective places. Number 2. This is why 2016 question 29. Yes. Number 2 now, why 2018 question 24. It said the position of equilibrium in a reversible reaction is affected by what? A. Particle size of the reactant. This one, the particle size is only affecting rate of chemical reaction. That is surface area. It does not affect equilibrium. Are we together? Yes. Then B. Vigorous stirring of the reactant mixture. No issue. Then presence of catalyst. They say the position. Catalyst does not affect equilibrium position. But it only makes equilibrium to be attained faster. Now D. Change in the concentration. So if concentration is not there, temperature will be there. If temperature is not there, pressure. 3 factors. So answer is what? D. Then number 3, a change in temperature of a saturated solution. I've explained what saturated solution is to you. A solution that contains the maximum amount of the solute can dissolve at that temperature. At a time, in the presence of undissolved solutes. After some time, the undissolved solute goes inside the solution, dissolve. While the dissolved one crystallize out. So there is no equilibrium between the undissolved solute and the what? Dissolved solute. So what is the answer here? A change in temperature of the saturated solution disturbs the equilibrium between the what? A. Undissolved solute and the solvent? No. Dissolved solute and the solvent? No. Dissolved solute and undissolved solute? Yes. So the dissolved solute and the dissolved. Then this is why 2015 question 35. Number 4. Which of the following factors will not affect the equilibrium constant? There are 3 factors. Concentration, pressure, and temperature. So which one is not there? Volume. So A. Concentration. B. Temperature. C. Pressure. The only one that is different is volume. Then number 5. Which of the following statements about chemical system in equilibrium is correct? The reaction is reversible. Yeah, that's number 1 point I gave to you. The The reaction must be reversible. It must proceed in both forward reaction and backward direction. B. Reaction goes to completion. No, the reaction must not go to completion. C. Equilibrium is re-established when a stress is applied. Yes. That stress is what I will explain under the Chatillon principle. The stress that is applied is when you change the temperature, when you change the pressure, and when you change the concentration. You are stressing the system. The equilibrium will not shift. Am I talking to you now? The answer here is what? Is C. Why not D? Equilibrium position is affected by catalyst. No. Catalyst does not affect equilibrium. It only makes the equilibrium to be attained quickly. Now, what is the effect of using vanadium 5 oxide as catalyst? What is the effect of catalyst? In the reaction above, A. Decreasing the value of delta H. No. Increasing the collision rate of reactant particles. No. Shift the equilibrium position. No, it doesn't shift the equilibrium. Now, reduces the time for attainment of equilibrium. Catalyst makes equilibrium to be attained faster. So that is the answer. Now, number 7. What is the expression for the equilibrium constant Kp for the following reaction? Look at the reaction. The formula is what? Product over reactant. What is the product? The product is what? 2NO. So it will not be what? No. D. NO. Raise to power what they use to balance it over the reactant. N. Nothing is used to balance it. You write it like that. Then O. Nothing is used to balance it. You do what? So answer is what? D. So now let's now look at some selected JAMB questions for this. Now let's look at these questions. Question number 8 is why 2006. Question 33. Consider the equation for this equilibrium reaction. Nitrogen reacting with hydrogen to give us ammonia. Delta H equals to minus 92 kJ per mole. The equilibrium constant for the reaction can be expressed as what? Product over reactant. Product is the product. You say D? No, cannot be D. Product. This one first. It's going to be this one, raised to power this 2, over this one, and this one in block bracket.
B.
That's option what? B. So, number 9, equilibrium is said to be attained in reversible reaction. When what happens? All the reactants are being used up. No, nothing will be used up. Because if anything is used up, the reaction will come to completion. All the products are being formed. No, not all of them are formed. There is no further change in temperature. No. The rate of the forward and backward reactions are equal. That is the answer. Number 10. Which of the following statements is or are correct about equilibrium? Number 1. Chemical equilibrium is attained when rates of backward and forward reactions are equal. That one is correct. Number 2. Changes in concentration of the reactants will alter equilibrium concentration. Yeah. Changes in concentration, changes in pressure, changes in temperature will affect equilibrium constraints. Then catalyst alters equally the rate of both forward and backward reaction. That's correct, but it does not affect equilibrium position. Then 4, temperature affects equilibrium constraint. Yeah, temperature, pressure, and pressure. Temperature, pressure, and concentration. So answer is 1, 2, 3, and 4. That's option D. Now, then the next number 11. You have this equation: ammonium chloride split to form ammonia. This is a dissociation reaction. Ammonia and hydrogen chloride gas. This is gas, not aqueous. Change it, please. Now, the reaction above can only attain equilibrium if what happens? A. It is in a closed system. Yes, that's the first condition for a system to be at equilibrium. It must be in a closed system. Why not B? It is an open system. If it is an open system, one of the reactants or the product will be escaped and the reaction will come to completion. So a reaction must not come to completion. So why not C? C says one of the product is removed. If one of the product is removed, then the reaction will come to completion. a gaseous reactant is added. If you add anything, reaction equilibrium will shift, so it's not correct. Now, number 12, dynamic equilibrium describes a situation where what happens? A reaction gives back the reactant. No, I didn't tell you that. The concentration of the reactant and products. The concentration of reactants and products is equal. No, they must not be equal, but they must remain constant. Both forward and back and reverse reaction proceed at the same rate. That is the answer. They must proceed at the same rate. R1 must be equal to R2. Reactants are converted to product. No. Number 13. Which of the following, which of the properties of reversible reaction is affected by catalyst? We have done that one last week. That's activation energy or energy of activation. Positive catalyst lowers activation energy and speed up the rate of chemical reaction. Now let's look at some other questions. Let's look at this question 14. In which way is equilibrium constant for the forward reaction related to that of the reverse reaction? Now, in which way is equilibrium constant for the forward reaction related to that of the reverse reaction? Equilibrium constant for the forward. When we're talking about Goubert and Watt's postulate of law of mass action, you remember? We say R1 equals to R2. K1 equals to K2. So equilibrium constants of both forward and backward they are called velocity constant, and it must be equal to each other. So what is the answer now? The addition of the two is expected to be 1. B. The product of the two is expected to be 1. No. The two equilibrium constants are identical. No. The product of the two is always greater than 1. What is the answer? The two equilibrium constants are identical. R1 equals to R2. So K1 equals to K2. Now, number 15. For a general equation of the nature xp plus yq equals to mr plus ns, the expression for the equilibrium constant is what? Product over reactant. What are the products? R raised to power m times what? R raised to power, where do we have R raised to power m here? On the top, R raised to power m, then what? Then s raised to power n over, what is the reactant? The reactant line is what? Where is the equation say? The reactant line is what? P raised to power what they use to balance it. Then times Q raised to power what? Y that they use to balance it. Answer is what? G. That is JAMB 1992 question 29. Then number 16, which is JAMB 1997 question 30. ME plus NF equal to PG plus QH. In the equation above, the equilibrium constant is given by what? It must be what? Product over reactant. G raised to power P in block bracket. Then H raised to power Q over N raised to power E times F raised to power N. E raised to power M, So what's the answer?
The answer is
G raised to power, what they use to balance it? Where is it? G raised to power P times H raised to power Q over E raised to power N times F raised to power N. Answer is C. So please don't joke with these kind of questions.
yes, sir.
Then look at this one too. We have even solved this one as number 1 before. You have the mission of solid, gas, solid and gas. Group the solid aside, the liquid, and the gaseous aside. So they say the equilibrium constant of the reaction above is what? Of this reaction above, What is the product? The product here, you choose the gaseous product, which is hydrogen. This is okay, yes. Hydrogen over water. Hydrogen over steam, that's option A. Hydrogen raised to power 4 that they use to balance it over steam raised to power 4 that they use to balance it. That is the answer, option A. Then theory question says list 3 properties of a system in a state of chemical equilibrium. I gave you how many properties? 8. Abi? But if they give you, always know what state this first theory. Concentration. Thank you. Concentration of both reverse and forward reaction must be what?
Constant.
Must be constant. That's how to state it too. Don't just say concentration. Must be constant. Temperature of both. You can say temperature must be constant. Temperature is the only one that has degrees. Must be constant. Then number 3, pressure must be constant. You can say must be constant, and you can say must be constant for both forward and backward reaction. You are correct.
They say theory.
The system, in case it comes, the system must be a closed what?
They say theory property.
Yes, I know. Must be a closed system. What else? The system must be reversible. Must be reversible. Catalyst reduces the time for the attainment of equilibrium. And they say we should state 3. So I think our time is fast spent now. So I mean in another